Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about ISRO's Gaganyaan test. So let's dive deep into it. So what exactly is the aim of ISRO here? Well, ISRO is planning to give India space wings. There are only 3 nations as of now that has space wings. So ISRO is trying to make sure that India becomes the fourth puppy. Now, rocket, we already had that. Project, Indian government was not green lighting that project, but that has been done. So rocket is a go, project is a go, and we are moving as planned. So things are working. And there is a oops here, is that you cannot do oops with human, meaning if you have Chandrayaan 2 that tries to land on the moon and it goes kaboom, that's bad, but not too bad. But imagine if you are sending people to basically low Earth orbit and people go boom, yeah, that's not acceptable. So fundamentally, there is a very serious reality where oops is not an acceptable answer when you have people involved. So when is the rocket most dangerous? Well, most powerful stage. Well, that's the launch pad. Launch pad, it has the most amount of chemical energy that is ever gonna have. Meaning the moment you launch the rocket, its total energy potential only starts to go down. So if you want this sort of thing, it has to happen on launch pad. So you have to, at launch pad, you are at the greatest amount of risk of turning into poof if something bad happens. And we have learned with be it India, be it Russia, be it America, we have learned it the hard way that things do tend to go oops once in a while. Not every time, but once in a while that does happen. So, because you have to understand fundamentally what is a rocket. Rocket is a big boomstick. Instead of going kaboom, it goes whoosh. And if something goes wrong, little bit things goes wrong, it goes really boom very quickly. So it is one of those things that we have to learn the hard way, that we must have a yeet plan out of there, meaning just go away. Now you may be like, okay, we have so much energy that you can put something in orbit. That is a tremendous amount of megajoule. How can you actually get out of it? Well, thankfully, we are talking about a combustion process. We are talking about deflagration, meaning the front, that things that is going to cause damage, it's subsonic. It's not going to move very fast. It's not detonation where it's going to go whoop. If it's a detonation, there is no point of building an escape system, because if you build an escape system, the g-force required to pull that puppy out of there would be so high that human will turn to paste. So it's pointless. So realistically, things do work out. The only reason these booms are so powerful is because you have liquid oxygen. The fuel itself is not that dangerous because our atmosphere has a containment mechanism known as nitrogen, 80% nitrogen. So that the fact that we have liquid oxygen makes it a bit more energetic. Thankfully, it's still limited by deflagration, so you only need around roughly 15 Gs of yeet energy. If you have 15 Gs of acceleration, you should be good. You should be able to get out. Now, 15 G is lethal to humans, but in short bursts, we should be able to survive it. Short bursts being generally a few seconds, not even a few whole seconds, where it's like continuously 15 G. It's like it has to be like 15 G jolt and then you slowly come down. That can be done. You cannot be like 15 G continuous. Yeah, you will literally go blind if you're lucky. If you are unlucky, literally internal organs would be like bye. So that's the aim. That's what ISRO is trying to do. Is like we have a rocket stick and we have to make sure that we have a yeet plan out of there. So do we have a history of this yeeting out of there? Well, yes. Soviet Union had a plan of known as T-10-1 that was tested, unfortunately, on 26 September 1983. That was the first known use of basically yeeting technology. It did work, did save the people's life, so good. And then we had Russia trying the same thing with Soyuz MS-10, which I'm pretty sure most of you know about this, that 4 boosters were there. They're supposed to be separated. One of them made a love tap that destroyed the booster, and yeet engine came into system, and it did work. That happened in 2018. Then we had same yeet system in Blue Origin, New Shepard 23rd mission, that was on 12 September 2022. Thankfully, no humans were involved, but it does prove the point that the system that Blue Origin designed does work. The system was there, it was armed, so it's just like, oh, booster in below me is going lol, how about I yeet out of there? It did work. It saved the capsule, everything is fine. If people were inside, or the only thing that would have been a bit rough is that G-shock. Now again, this G-shock would not be same as like a launch pad directly going from 0 to full speed. So, but it did prove the fact that if something bad would have happened in the system, the yeet system is working. Yeet system has proven to save lives. However, Challenger disaster was like a very sharp, like brought some things into focus. For example, this puppy, meaning you can see that shuttle is there, and that booster started to leak fire. That was a very early sign that we realized that, yeah, you can see that booster's O-ring failure happened, and it started to spit fire. At that point in time, the fate of 7 people on that craft were sealed. Basically, it was like nothing can be done. And this was the first bitch slap that America got. The second bitch slap was another space shuttle disaster. After that, they were like, no, thou shall not have any manned system that does not have escape systems. We learned it the hard way that you will not design a system that does not have emergency escape system, because this was actually preventable if they had any system. Like, unfortunately, they did not had a system. You may be like, don't they had ejection seat? Ejection seat was in the early iteration. That was a prototype iteration, meaning they were like, they built the system and they had tested. So they put 2 people, but that 2 people had the luxury of ejection seat, and those ejection seat would only work at very low altitude. At very high altitude like this, it may not have worked. And there was a serious issue that even if you yeet out of there, the solid booster has such a big plume that when you're going there, yeah, the plume will poof you out of existence. So there was no actual, they needed a capsule, but there was no design for that. But after this, people have realized that thou shall not put humans unless you have emergency escape system. All modern system, be it made by SpaceX, be it made by Blue Origin, be it made by Boeing, be it made by SLS, whatever have you, all of them have yeet energy. Now you may be like, isn't Starship something that does not have emergency escape system? Then how the heck Starship, that's supposed to be human certified, does not have emergency escape system? Well, you have to understand, there is 2 versions of Starship. One is Elon Musk weed, one is reality. Now Elon Musk weed, he's going to use it as an airline. That's weed, don't think about it, don't smoke that much. And then you have the second one, that is NASA's design. NASA designing, you make a rocket, you launch that puppy, we're going to use your own company's Dragon to send people there, or our own design hyper expensive Orion to send people up there. So people will only be carried by things that have yeet technology. So we have learned it the hard way that must have emergency escape system. And again, could Starship ever become so reliable that it does not need escape system? Well, no. Soyuz was very successful. Soyuz was very successful. People never shut up about successful. And then this happened. So we have learned it the hard way. That so basically what NASA is trying to do is basically use SpaceX as a bus, and then use a small basically taxi that is safe. So they will go the bus either goes boom or goes successfully there. If it's successfully there, it is in a low energy state. It no longer has the chemical propellant to go poof. So then they can transfer very safely. So that's the history aspect and the things that are happening right now. So what was the test of India's design? Well, India's design was this puppy. We have a capsule here. Now, yes, it's completely covered by the shield that is there to protect against rocket exhaust. So in-flight abort system was tested, and that testing happened at Mach 1.2. So module separation, basically rocket is pushing it, and then at that point, the yeet engine will just fire that puppy. Basically separation will happen. Now, this system is known as Test Vehicle Demonstration 1, very simple name. And the crew module was the main thing that they had to test. Now crew module, basically where people would be, that puppy is around 4.5 ton, around 4,520 kilogram, and touchdown velocity is 8.5 meter per second. So it's not the most smoothest, but it's designed for a splashdown in the sea, which is more than good enough. It's easily survivable. Heck, many systems do have that. Now it has 2 series of rockets. You have low altitude escape motor, that is LEM. Then they have high altitude escape motor, that is HEM. Now it's the same thing in Russian system also, because Russia also has a tractor system. But once they reach high enough altitude, this yeets out of there to give you most delta V. But what if you have to do ejection at that point? That was tested in 2018. It uses different system. It uses, instead of puller design, pusher design. So same thing we have here. We have 2 series, but all of them are in tractor itself. But you have 2 for one simple reason: the rocket nozzles have been optimized. So rocket nozzles that are optimized for low Earth, basically low Earth, I'm saying low altitude, is designed from launch pad to early few thousand feet. From there, it's like, bro, I got this. I have the thrust, I have the coupling efficiency of a good nozzle. We good, we go. But once you go high enough in altitude, at that point, high altitude motor will be like, bro, I have got this. I have enough nozzle, space so that I can couple energy efficiently. or you can just brute force all of them. But this is the approach that ISRO took. So we launched it, and the separation happened. Then we had coasting phase. Then we had crew module separation. Then crew module reoriented itself, deployed a drop chute. Drop chute pulled out the main puppies. Main puppies slowed down everything, and splashdown happened. That was the plan. So what was the result? Well, this puppy was tested on 21st October, 21st October 2023, and universal time was 4:30 a.m. Early morning, and in India time that's 10 a.m. in the morning. So this. Now it was launched from Satish Dhawan Space Center. That puppy, you can see the name, and it did everything perfectly, and the main parachute deployed at 2.5 kilometers, so there were more than ample time to comfortably relax, chillax, and then have communication and all that jazz. Everything was fine. And then INS Shakti was in the Bay of Bengal to doing the capture mission. Basically, once it lands in the sea, so there has to be a ship to capture it. Now this ship, that INS Shakti, is very interesting ship because it's a fleet tanker. Basically, this puppy allows other puppies to fight in the battle, because you can have a battleship, you can have aircraft carrier. And yes, this puppy had fueled American aircraft in 2012. And you're like, wait a minute, aren't American aircraft carriers are nuclear powered? Yeah, the craft is nuclear powered. The planes on them still require fuel. So yes, this is a fleet recharger, so to say. So they have a lot of flat deck space and a lot of cranes and auxiliary equipment that you may not think to put in a battleship, but these sort of things require it. So for that reason, ISRO is like, hey, good match, we're gonna use you. So that's why this puppy was used. And thankfully, in the backside of it, it also has a giant helipad, so it can handle some big, heavy puppies. Benefit of that, once you have collected the people, you can put them into helicopters and just yeet them out of there as quickly as possible. And it was done on a bit of a rough weather, not very rough, but rough weather. But again, it's a battleship kind of ready kind of scenario. It does have some offensive capabilities. So results was positive, and INS, basically Indian Navy and ISRO worked together, so everybody happy. So what we can expect in the future? Well, the reality is, one day before I die, I will hope that ISRO freaking uses a camera that is made in 2020. I am freaking tired. I'm not even joking. If you watch the live stream, they literally have a thermal camera that has better frame rates than the color camera. And the color cameras literally looks like it was copy pasted from, I don't even think 1990s had such a garbage quality. It's like, I'm genuinely sure. I want to meet the maker who is making such a garbage camera. It's like, how are you making it so bad? Like, genuinely. Like, cheap Chinese clones are so good now. It's like, how? I really want to see good footage out of it. But someday, maybe somebody in ISRO figures out that it's actually wise to spend money on cameras, because again, you want public support, you want to show public a good, nice image. If you do not show that, people get bored. So someday. Now, testing unit of this project is basically a brick. Now, could we do another launch escape system? Yes, most likely. This was more close to somewhere in between pad launch and pad launch we have already done. In principle, we have already done pad launch. This was second early stage. Then the worst case scenario is max Q launch, which again, based on the data that is being crunched right now, they may decide they need max Q abort such testing or not. So things are progressing brick by brick. Now, aim is the maiden launch supposed to happen in second quarter of 2024. It would be uncrewed, exactly how Buran space shuttle did that. Basically, it went into orbit, everything checked out, but there was no human inside. So that will happen in 2024. And this puppy, basically rocket is already tested, and what we are doing with human certification, basically we are increasing its margin of safety. Nothing inherently we are changing, but it's just like, are we damn sure that this puppy is going to work rather than going kaboom? So that's there, and hopefully by 2025 we're gonna have a crewed launch. Now, target is 2 to 3 people, astronauts, and a 7-day maximum stay. Now, is that upcoming? Well, no, this is a bit early stages. This is early stages of space exploration. But again, if things go well, we are on track to become the 4th nation to put people on the space. So let that sink in. Be mindful, there are more than enough countries, and I'm reasonably sure if you really think hard, you can think of more than 50 countries in this planet. So being in 4th, not that bad. We good. So this early start, which again, compared to other options, it may look like a bit outdated. But again, if we are just starting it out, more than good enough. If it starts get going, once we have good publicity, once we have good flow, then we are like, we can keep doing things. So I do expect in the future, hopefully, we're gonna have better cameras. This is the mission patch that was done. So this was my presentation on basically ISRO's testing of Gaganyaan. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.